Right, everybody. So we're gonna make a little short and sweet recording here. Yeah. I'm gonna put this up in a second. All right, that worked. So I think we finished our conversation last week for the different types of matter. We have just 1 and 2 reprobations. That stuff that you already know, just kind of formalize it. Different states of the matter. When we say states, we mean the physical states, okay? For instance, when you have salt water, it's liquid, but when you start evaporating it, you have 2 additional physical states of matter that you can observe. The solid salt, and the one that you cannot really observe, the water vapors above it. So, what are the characteristics of the different states of the matter? So first of all, solids, okay? To formalize it, all solids have a particular shape, like this amethyst, okay? A very specific volume. They're fluid, okay? And that happens, the specific volume and the specific shape, they have it because the particles, atoms, or molecules inside of the solid are arranged in a very specific manner, very specific order that does not change with time. Does that make sense? So all atoms or molecules in amethyst, they are connected to each other by chemical bonds, and they do not move a lot. You can think of it, if you want something, more kind of a sort of an analogy. Imagine that you have a bunch of balls that are connected to each other by sticks, fairly thin sticks. If you will try to shake this structure that you built, it's going to shake all right, but it's not going to disassemble. Does that make sense? So it's going to maintain its structure. Now, liquids do not have a particular shape. The shape is indefinite. But liquids always occupy a specific volume. If you have 1 liter of milk, it's going to occupy a volume of 1 liter. It's not going to occupy, if you pour, let me explain what I mean here. If you pour 1 liter of milk into 2-liter jar, it's still going to have a volume of 1 liter. It's not going to fill the jar all the way to the top. Does that make sense? Yeah. But the shape, as you may imagine, they're different. They acquire actually the shape of the container. Okay? Now, particles, if we use that same analogy with the sticks and balls, particles close together, but they're not linked to each other. Can you see that? The molecules of water in this illustration, they are not connected to each other by chemical bonds. So they can move relatively to each other. Does that make sense to you? So imagine that instead of balls with the sticks, you just have balls. Okay? So they still stay pretty close to each other, but they will be fluid. Right? Finally, gases. So gases have no particular shape. And what's important, they have no finite volume. That may sound odd, but if you think about it, if you will take all air that fills that room, somehow, suck it out of that room, and we'll pump it into a small tank. You can do it, just to increase the pressure in the tank. Does that make sense? So basically, when you inflate a tire or inflate a balloon, you package a lot of gas into a restricted volume. Does that make sense? So they will occupy the volume that you will provide for them. Does that make sense? They may occupy a 1 liter, they may occupy 10 liters. All right? The density will be different. Particles in the gas are really far apart. Does that make sense? And particles in the gas move very fast. Now, one consequence of this, kind of thinking about it, I want to just say a few words about the change of physical state. Imagine that you have gas. Particles move fast. They are very far apart, like on this illustration. Okay? And these particles occupy a certain volume. Now you start to reduce that volume somehow. I don't know. Kind of start to squeeze them together. Okay? Now particles become less and less far apart and then become closer and closer to each other. As they become closer to each other, how will it affect the rate of movement, rate of motion? They're going to slow down. Particles, when they're close to each other and they move slowly. Which physical state is characterized by this? Liquid. So, which means that if you take a gas and start squeezing it really, really hard, okay, you will turn it into a liquid. And in fact, if you will take air and we'll squeeze it very hard, okay, with some extra things that you will have to do, but it will be converted into liquid. Does that make sense? So by pressure or by cooling down, by slowing down the particles, you can convert gas into the liquid. Okay? Not for all chemicals, not for all compounds. It works, but for many it does. Okay? Now this table here shows you the comparison between the solid, the liquid, and the gas. Now those of you who may have heard about the fourth state, so-called plasma state, may wonder why we don't talk about plasma. The chemistry of the reactions that happen in plasma is out of our concern, let's put it this way, just too hot, okay, too weird. The particles are all charged, so just let's not talk about plasma, let's focus on these three, okay. So this table is a pretty nice comparison. Now, I don't think you will have any troubles identifying a solid, a liquid, or a gas. But in terms of the questions on the quiz, you should be able to match a characteristic with the state. So say I tell you it has a definite volume but indefinite shape. Think, okay, definite volume, indefinite. That sounds like liquid. Okay, so match. Liquid. Got it? And so on and so forth. And that, all in that kind of sense. Does that make sense? I will try my best to base all the questions on like these statements. So you don't have to readjust your learning to my vocabulary. You good? Okay. Now, what's the difference between physical and chemical properties? So physical properties are the characteristics that belong to the substance and can change without substance changing. Very complicated, much simpler to explain. You take a chunk of lead and you melt it. Does it change its physical properties? Yeah, it goes from solid to liquid. Is it still lead? Yeah. So chemically, it's the same compound. Okay? Water, ice, liquid water, water vapors. It's all water. Chemically, it's the same compound, but it has different physical properties in each of its states. Does that make sense? Moreover, I can tell you that, as far as I know, ice, simple ice, can exist in 17 different forms, different crystal forms. They form at different temperatures, different pressures, they differ in organization of the crystal structure. But the point is, it's all ice. It's physically different. It has, all those forms have different density and whatnot, but it's all chemically water, H2O. Does that make sense? So physical properties change, but the identity of the compound, of the substance, doesn't. Right? Well, great example. Carbon. Graphite in your pencils, that's carbon. The coal is carbon, and the diamond is carbon. You probably cannot imagine anything more different than graphite and diamond, but they chemically are identical. Does that make sense? Here's the examples. Like, you can characterize physical properties of copper here, right? So, color, red, shiny, conducts electricity and heat really well, has certain melting and boiling points. Okay? Now, let's just play with it a little bit. So, physical properties of graphite, the stuff that you write with. The color, gray. I don't know the melting point, so we're not going to focus on that. Is it shiny? Sort of, kind of, yeah, like matte maybe. Is it soft? You can break it. I mean, okay, it's not soft, but it's kind of fragile, right? It's not mechanically resilient. Now, diamond, the color, ideally, clear. Hardness, very hard. Shiny, well, supposed to be, right? And melting point is something absolutely like atmospheric, over the top. Okay? Different physical properties, same chemical. So you have to be able, on the example, to identify that what is the physical property or what is the chemical property. Okay? Now, okay, kind of running ahead of a train, few words. Chemical property. What we described are physical properties. Now, can you burn carbon, whether it's a diamond or graphite or coal? Yes, that's the chemical property. It can burn in oxygen. Does that make sense? Okay. Copper versus platinum. If you will put platinum or gold outside and just leave it there, will it stay shiny? Well, if you ever been in Russia, you will know it will, because it covers, gold covers all the heads of the churches. If you put copper outside, like you build a copper statue, it's gonna get tarnished, right? So that's chemical property. Copper interacts with oxygen much more intensely than gold does. Does that make sense? So that's the difference between chemical property and physical property. All right? Now, at this point, we're going to pause it.